In this question, we're told the discrete random variable x has the following probability distribution. So probability x is equal to x is given by k over x for x equals to 2, 3, 4 and 6. Probability x is equal to x is 0 otherwise. So the first part of the question asks us to show that k is equal to 4/5. In order to ask this question, first thing I'm going to do is I'm going to write out the probability distribution. So we're going to have our x values and then probability x equals x. So I'm just going to tabulate it. I find personally the easiest way to organise this is to tabulate it. So we get the x values at 2, 3, 4 and 6. And so probability of each of these, we get k over x, so I get k over 2, k over 3, k over 4 and k over 6. So now I want to show that k is equal to 4/5. What we're going to do is we're going to use the summation of all the probabilities. So this is just the rule of total probability we know is equal to 1. So we're going to have k over 2 plus k over 3 plus k over 4 plus k over 6 is equal to 1. What I need to do to add up all these fractions is we need a common denominator. Lowest common multiple of 2, 3, 4 and 6 is 12. So I can put all of these over 12. K over 2 would be 6k over 12, plus k over 3 would be 4k over 12. K over 4 would be 3k over 12, and in k over 6 would be 2k over 12. So this is all equal to 1. If I multiply both sides by 12 now, we get left with 6k plus 4k, we get 15k equals 12, and then if I divide by the 15, that's when we finally get that k is 12 over 15, which cancels to give us 4 over 5 as required. Okay, so part B says find the expectation of x. Expectation of x would be a little bit easier if I've got my probabilities written out. So I'm just going to squeeze them into my table. K over 2, so 4/5 divided by 2 is going to be 4/10. 4/5 divided by 3 is going to be 4/15. 4/5 divided by 4 is going to be 1/5. And then 4/5 divided by 6 is going to give me 4 over 30, which can cancel to 2 over 15. So now, expectation of x. This is given as the x value times the probability. It's a summation for all values, so it's 2 times 4/10, which I could have really written as 2/5. So 2 times 2/5 plus 3 times 4 over 15 plus 4 times 1/5 plus 6 times 2 over 15. Make sure you show you're working. If we work through this and calculate this on your calculator in one go, you should get an answer of 3.2. Okay, part C says given that x1 and x2 are independent observations from the distribution of x, determine the probability that the product x1, x2 is equal to 12. So part C, I'm looking to find probability x1, x2 equals 12. Put a bracket in the wrong place there. Let's just tidy that up then. x2 pen equal to 12. So the ways this can happen, we could have probability x1 equals 2 and x2 equals 6 plus probability x1 equals 3 and x2 equals 4 plus probability x1 equals 4 and x2 equals 3 plus the probability x1 equals 6 and x2 equals 2. Sorry, I'm just squeezing it in at the end there. So then just calculating these, remember these are independent probabilities. So what we're going to do is we're going to do probability of x equals 2, which is 2/5, times probability of x equals 6, which is 2/15, plus probability x is equal to 3, which is 4/15, times by probability x equals 4, which is 1/5. Now actually, at this point, what I'm going to do for x1 equals 4 and x2 equals 3 is exactly the same as this. And what I'm going to do for x1 equals 6 and x equals 2 is exactly the same as this. So what I'm going to do is I'm just going to calculate these two values and double it up, rather than just recalculating the same probabilities over and over again. There's nothing wrong with listing it all, just looking to save space and a little bit of time. So if you type this in carefully and work through this on your calculator, you should come up with an answer of 16/75. Okay then, so let's have a look to see how the marks are awarded in this question. First of all, there is a method mark for using the summation of probabilities is equal to 1. And then finally, there is an answer mark if you've got that convincing argument that gets us to k equals 4/5. Part B, there is a method mark if you have shown the working for calculating the expectation of x. Remember to show that full calculation. And then an answer mark for getting that the expectation of x is 3.2. Next, there is an answer mark if you have correctly, standalone mark, if you have correctly identified all the pairs of observations that will give us a product of 12. There is then a method mark and an answer mark for the correct method with the correct values for calculating this probability. And finally, there is an answer mark if you got all the way to the probability of x1 times x2 is equal to 12 is equal to 16/75 or an equivalent. Okay then, well I hope you understood my answer and you followed how to mark the question.